All right, so we're going to spend the next half of class using this equation, which is going to help us model exponential growth and decay functions. So I've gone ahead and started this recording here so you guys can take a look at this slide here, which we're going to be focused on this equation. So again, I just want to read it for you first so you can see how we're going to use it. So it's read as A of t is equal to A times 1 plus or minus r, all raised to a power of t. So you can see that all these things represent different information. And we have the final amount is the very beginning. That's the A of t, so the amount at time t. The lowercase a is the initial amount, so what we're starting with. And then when I read the inside of the parentheses, I said plus or minus. So again, you need to pick plus or pick minus. So you have to decide, is it growth? That's where you use addition. Is it decay? That's where you use subtraction. We have r as our rate, which will be our percentage. And then finally, in the exponent is our variable time t. So that will represent days, months, years, minutes, something related to time. So I want to show you a quick example of how we're going to use this. This example with Clara and investing $5,000 into a savings account. So I know you guys probably don't have your own savings accounts yet, but you will in the future. And the way this works is you deposit your money into a bank, so whether that's Chase, Bank of America, Wells Fargo, whatever bank it is. And what they do with that money is they use that money then to loan to other people, like for mortgages, for houses. They use it to finance other different things into the market. Whatever it may be, they're using that money that you deposited, and to pay you for that, so like say as a thank you for letting them use your money, they deposit money into your account usually every month. That's when interest is put into your account. So in this case, for Clara, it'll be 1% of whatever she's got in there. That's what the bank puts in. So it's basically your money is sitting there doing nothing, but it's making money each month. So I'm going to go ahead and use our equation. A of t equals our lowercase a times, and this is where I'm going to decide, is this growth or decay, or her money is increasing or growing. So we're going to write plus in the parentheses here, 1 plus our rate, all raised to a power of t. All right, so now with the information I'm given, I'm going to replace that. We still don't know what our final amount is. It says initially she deposits $5,000. And we're going to do 1 plus our rate. So again, our rate is given as a percentage, which is 1%, but you should always write it as a decimal when you go ahead and put it in the parentheses and raised to a power of t. So you notice my 1% is 0.01. And that's basically it, but I always go ahead and clean up the parentheses real quick. So I'm going to write A of t equals 5,000 times 1.01, so I added those to the power of t. And that's it. So that is our equation that's modeling this exponential growth. Now again, right now that's all I want you to do, just write the model, write the equation. But in the future, I'm going to ask you certain things about these types of problems. For example, how many years will it take for Clara to double her money? All right, we're going to be solving that. Or in 10 years, how much money is in Clara's savings account? So we'll be looking at that and seeing how we can use equations like this to do those things. So I'm going to let you guys go ahead and go to your boards. You're going to try these two here where you're reading the situation and then writing the model. Good luck.